Combining functions, add, subtract, multiply, and divide, the basics. So, you add, subtract, multiply, and divide polynomials, and functions oftentimes are polynomials, but they're oftentimes something else. So we're just expanding on that. So when we add, subtract, multiply, divide two that are polynomials, it's the same thing that you've done before. But when it becomes a rational or a radical or something like that, it may be a little new to you. So I'm going to do those things, the four basic operations with functions, and we're going to talk about notation a little bit. So I'm calling this an intuitive approach, and let's go over some notation, because if you just saw, given f of x and g of x, if you just saw f plus g, if you just saw that right there, you would probably guess, oh, that just means take function f and add it to function g. You would probably just do that anyway. That's why I call it an intuitive approach. It's something that you would, again, just most likely, if you didn't have any training, didn't have any idea what to do, where to start, you would say, oh, if I had to guess, I'd guess here. You'd guess right. Okay? Another way to write it, see, you can have f plus g here, or you can have f plus g of x. That's not times x. It's function notation. It's of x. All right? So, same thing with minus. F minus g is f of x minus g of x, and you can also have f minus g of x. So I'm writing it two different ways here. That's all the left and the right is. Just two different ways that it's written. And then fg, if you don't put anything between it, remember in math and algebra, I should say, that means multiply something. So it's fg of x is f of x times g of x. The other way that I've written this is put brackets or parentheses around these. Say multiply them that way. All right. And then f over g or f over g of x means f of x over g of x, where g of x is not equal to 0. So if you talk about the domain of combined functions, okay, it's the intersection of the domains of f and g in this case, whatever you're combining. The other caveat there, the other little piece is you've got to remember that if I introduce this division piece, g of x can't be 0. So even though g may have its own domain and you intersect it with f, you also have to take the parts out where g is 0, whatever you're dividing by, whatever that function is. It doesn't have to be called g of x, but it's the one you're dividing by. So that's why I wrote this, and g of x is not equal to 0 over here in parentheses. So here, give the following functions, find and simplify, right? So if we look at these, all four of these, f, g, h, and p are all polynomials. So unless I divide by something, then the only thing that's going to be a restriction on the domain is when that denominator is equal to 0. So I'm not going to talk about the domains on these, but just understand they're there. And a lot of times these software packages, whether it be, there used to be something called EduSpace a long time ago, the My Math Lab and Hawk's Learning Systems and all kind of stuff, all right? They're not as free maybe as your teacher. When your teacher makes a test, their own test, they can ask what they want to. But when they choose the software, for example, the class I use right now, when I ask this question, it has domain attached to it, and I can't take it off. So then I don't necessarily go over it, and I've already gone over domain, but then students get there, and they hem-haw around and have trouble with it a little bit. So, but I can't take that off of the package there. Can't remove that part from the question. So here, f plus p. F plus p, that just means f of x plus p of x. Well, f of x is 3x squared minus 5x plus 7. That's f of x, plus p of x is... You don't necessarily have to have parentheses when it's plus, because if you distribute a plus sign, it doesn't change any signs or anything after it. But just to get the idea of what's going on, this is f plus p, okay? That's f plus p. Now, I'm a big fan. I have a lot of students who do this and like this. I'm a big fan of saying 3x squared minus 5x plus 7, and then 2x squared plus 4x minus 11. And what kind of 2x squared is that? Positive. The plus sign doesn't change it. So when you do this, 3x squared plus 2x squared is 5x squared. That's going to be minus x and then minus 4. And that is your final answer there. All right. To line it up vertically, that kind of thing, it's a good thing to do there. Line that up vertically. But you don't have to. You don't have to. So f minus p of x. All right, so the next one, f minus p of x. So really what this really means is f of x minus p of x. So it's really the same thing I just had, 3x squared minus 5x plus 7, and then minus, now this time the parentheses around p back here must be there because what are you doing? You're distributing a negative here, right? So this is f minus p right here, right? So that's the negative. After the negative, the parentheses are necessary, not before, because you're not distributing anything. So again, when I come out here, I might say, okay, what does this equal to? Well, I might line it up again. I like to line it up again. And what I've found over the years is my students prefer this method. So I'm going to write 2x squared, 4x, and 11 with no signs on it when I subtract. Okay? So, and then I go back and go, okay, if I distribute the negative, this becomes negative, and this becomes positive. Now, if I was doing this in polynomials when I'm introducing this, right, prior in algebra, I'm going to distribute, show that, I'm going to show this. I'm going to put minus 2x squared minus 4x plus 11. I'm going to show that and then say, okay, now bring it over here to this, okay? But here, at this level, I'm going to say, hey, do that as you write it down, change all those signs. All right? So this is going to be what? X squared minus 9x plus 18. And that's that answer right there, okay? X squared minus 9x plus 18 for f minus p of x. All right, so let's look at some more here, and I'm just going to keep the functions the same right now. I'll keep the functions the same for several of these, and we'll do several of them, and then we'll go from there. So h over f, that really means h of x over f of x. All right, let me fix that. Which is h of x is 5x plus 9. And we want our fraction line to go over and under everything. And we also never use a slanted fraction here. Right? So, and I gave you something here. If you try to factor that, that's not going to factor. So if you had to go find the numbers that were not in the domain, it'd be the quadratic formula or something, and it'd have square roots and it'd be intense. Maybe I should have gave you something to factor, made it easier and talked about it. But the main thing I'm doing here is, hey, what do you do when you have h over f? It means h of x over f of x, right? But the domain would be restricted because you now have a denominator, right? That's what the rules of domain are. So here, 5x plus 9. Now, I would want you to simplify it if this factored. I would want you to simplify it if 5x plus 9 factored out, but it doesn't, so you don't have to worry about it here. All right, so h of x over f of x here. And then p minus g of 3. Now what this is really going to be, this is going to be a minus, and in the minus you're going to have p of 3 minus g of 3. Okay? P of 3 minus g of 3. Now there's different ways to work this. I have seen it work where you find p minus g, you find that function first with x's or whatever variable you have, and then you plug in the 3 at the end. I choose to do it this way, p of 3 minus g of 3. And so what I'm doing is I'm going to have equals, and I'm going to have something minus something else. Well, what I like to do, I love thought clouds, right? So I'm going to say p of 3 equals what? Where's p? 2 times 3 squared plus 4 times 3 minus 11, right? So I'm going to have me a little thought cloud, or as my daughter calls them, thought bubbles, okay? As she has grown older, she finally entered my world of algebra in middle school a few years ago, and it became much better when I tried to help her with math. Before then, she always cried. I just didn't know how to do it, right? Now she's in my realm, my world, right? So she loves thought bubbles, as she calls them, all right? So then here, this is going to be 2 times 9 plus 12 minus 11. This is going to be 18, right, when you do that. And then that's going to be plus 1. That's going to be 19. So this is going to be 19. And then I have minus whatever g of 3 happens to be, okay? Whatever g of 3 happens to be. Well, let's look at g of 3. And I'm going to do g of 3. And the rule for g says 3 times x, which is 3 minus 1, and this is going to go in a thought cloud, okay? So I just have a thought cloud, a yellow one and a gray one, trying to find out what P of 3 is and what G of 3 is, and I'm putting them back in. P of 3 is 19 minus whatever I get for G of 3. So 3 times 3 is 9, minus 1 is 8. So then 8. And if I had a negative, I put negative 8 and put it in parentheses, but I don't have a negative 8 here. It's just 8. But minus, this minus is here and then here, right? It stays in the formula, if you will, the equation there. So then we're going to come back and say 19 minus 8 is what? 11. 11, and there's my final answer. P of 3 minus G of 3, P minus G of 3 is 11. Okay? So let me say something real quick. I did not say this earlier. When you have H over F, this just means use the, so these are X's, is why I put X here. If that had been a P, this would have been a P right here. You with me? So whatever variable you're given in, assume the assumption is you will use that variable. So here, everything's given in X's, so I used X's, but it can be other variables as well, okay? It can be other things as well. So let's look at another GH of negative 1. That's of, not times, it's of. You read this as GH of negative 1, or you can even say G times H of negative 1. So what do you suppose that means? Well, it means we're going to take something times something else, and those two somethings are going to be G of negative 1 and H of negative 1, okay? So as we go through this, as we work through this, we're going to have some thought clouds or thought bubbles, and we're going to have two things multiplied together, and then equals whatever our final answer is here. So I'm going to have a blue bubble or thought cloud and an orange one. Again, thought clouds, I use them for various reasons. One is I'm working on something that's not really equal to what it is, but helps me solve it, which is very rare in math. I use that in my bottoms-up factoring video. But most of the time, it means I'm working part of a problem, and when I get the answer to that part, that's only a part that goes back in. So rather than rewrite the whole problem over and over and over again, I'm going to go to the side and work it. Like if I'm doing a big fraction, a big rational expression where the denominator is already factored and ready to go, but I have 7 steps left on the numerator, well, rather than write that entire fraction 7 more times, I'll go out in a thought cloud and I'll simplify the numerator, the 7 steps, and then bring it back into my fraction on the next step. Okay? So here, I'm just going to do the blue and the orange as separate little thought clouds over here. So in my blue one here, G of negative 1 says 3 times negative 1 minus 1. So it's going to be negative 3 minus 1 is negative 4. So negative 4. That one's pretty short and simple and sweet. And then H. Oh, H is too. Look at that. So then H of negative 1 is going to be 5 times negative 1 plus 9. Is that right? It's going to be negative 5 plus 9, and that's going to be a positive 4 this time. So we got negative 4 times positive 4. And that goes back in, right? G of negative 1, that's negative 4, times H of negative 1, that's positive 4. What is negative 4 times positive 4? Negative 16. And there it is. Boom. There it is. And then P over F of 2, what do you suppose that means? Well, that just means P, oops, this thing's going to be a fraction. This thing's going to be a fraction. And then the top, the numerator, you're going to get P of 2. And then the denominator, the bottom, you're going to get what? F of 2. All right, let's make sure that's a lowercase f. So I still have my fraction. I'm still going to come down here and go, okay, whatever. And then whatever I get here, if I get, something that simplifies, simplified. If I don't, leave it. So there's my fraction. Let's go over here now. I'm going to have a blue and a green thought cloud, right? These thought clouds are going to be a little bit bigger. So P of 2 equals 2 times 2 squared plus 4 times 2 minus 11. Right, P, right here. Plugging in 2 for X right there, right? So this is going to be 2 times 2 squared is 4 plus 8 minus 11. So this is going to be 2 times 4 is 8. And then if I put plus 8 minus 11, that's minus 3. And that gives me what? 5. So in the numerator, I get 5 over, now the denominator. Let's see what happens when I do this. Let's see, F of 2. So it's going to be F of 2 is going to be 3 times 2 squared minus 5 times 2 plus 7. So this is going to be my little green thought cloud over here for this one. Okay, so it's going to be 3 times, not 9, I don't know where I got 9 from. That's 4. 3 times 4. Minus 10, right? If I put those together, negative 5 times 2 is negative 10. And then plus 7, right? So 3 times 4 is 12. And then if I put those together, that's minus 3 again. That's going to be what? 12 minus 3 is 9. So then this here is 9. And I say, okay, can I simplify 5 over 9? The answer is no, I cannot simplify 5 over 9. There's nothing that can happen to that. So my final answer here is 5/9, or 5 over 9. Okay? Can't do anything else with that. So you can either plug in a variable, or if you're not given a variable, like the h over f, the thing I told you about, you assume that it's whatever variable it's given in. So in that case, x. Or if you're given a number, you plug it in. But here in this case, when you're add, subtract, multiply, and divide, you have to plug in the number to both of them. You can also, I could have found the function p over f first in terms of x's and then plugged in 2. I could have done that. All right? But I would prefer to plug in the numbers and get the numbers and then do the operation, whether it's add, subtract, multiply, or divide, after I plug each one in individually. Because typically we're better at plugging the numbers in and simplifying than we are at simplifying a bunch of x's and algebraic stuff. All right. The big deal, though, is order of operations. All right. And then when you have fractions, don't use a slanted fraction. It's not wrong on 5/9, but don't use a slanted fraction, especially if you leave the x's in there. And then here, I just wanted to give you one that was kind of crazy. F plus P minus G. Really? Really? Okay. So this is going to be f of x plus p of x minus g of x. So it's going to be f of x is 3x squared minus 5x plus 7 plus p, 2x squared plus 4x minus 11, minus g is 3x minus 1, but that's got to go in parentheses. Right? So again, I love to do this vertically. I love to do this vertically. So I would like to come out here and go, okay, 3x squared, minus 5x plus 7, and then 2x squared, which is positive, so put a plus there if it's not the first line, because when you add or subtract, you do that, minus 11 here. And then, look, if I distribute the negative, I've got a 3x and a 1, but wait a minute, I got a negative 3x and a positive 1 now, right, because I changed my signs. So there's my vertical there. So this is going to be 5x squared, then negative 5 and 4 is negative 1, minus 3 is negative 4x, and then 7 minus 11 is negative 4, plus 1 is negative 3. So there's your final answer there of, if you want to write it over here, you can leave it over there, it doesn't matter, equals 5x squared minus 4x minus 3. All right? So I lined it all up vertically and just kept up with it as I went. All right? Also had to change my signs because it was a minus. There's different ways you could have done that horizontal. You could have done the first two together, which we already knew, by the way. We did f plus p first. You could have taken that function and just subtracted the g of x by changing the signs and then combining like terms. Look, just because I did this way doesn't mean it's the only way. All right? Now, if you have a teacher, professor, or instructor that says, hey, you better do it this way, then you better do what they want. They're your teacher. Okay? They're the one grading your papers. So you do what they want you to do. In my class, only a few times do I care if you do it a certain way, all right? And I tell you up front, hey, I'm going to ask you this method, so you better know how to do it. Otherwise, if you use a correct mathematical method, I'm supposed to be smart enough to know that, and I'm going to give you credit. All right, here we have HP. So what this means is H of X times P of X. And you can use a dot, or you could write it, bigger brackets. You could do something like, brackets around this without the dot there, but just showing you that's what you could do. So H of X times P of X. So what I'm going to do is I'm going to do the H of X in blue, which is this function. Let me circle the whole thing. It's this function right here. And then I'm going to do the P of X in, let's see what color, the yellow, I guess, right here. So the P of X is this one right here. All right, so we're going to take this back. We're going to say, okay, we're going to have H of X times P of X. And this time I'm going to use parentheses because I have more than one term, right? So my H of X we said was what? 5x plus 9. And my P of X is the 2x squared plus 4x minus 11, right? So I have 2 terms times 3 terms. This is bigger than FOIL, remember. All right, there's no word for it like foamy moil or something like that. So it's just what it is, the thing that it is. It's bigger. But what you're going to do is you're going to take the 5x and you're going to distribute it to all three of these. So the 5x times the 2x squared is going to be what? 10x to the third, right? Because you have 1x and 2 more x's has to give you 3. 5 times 2 is 10. And then I'm just going to continue changing colors here. 5x times the positive 4x, that's going to be plus 20, and that's going to be x squared, right? And then we're just going to keep swapping them up here, and then we're going to do this 5x all the way times a negative 11. So that's going to be minus 55x. And then as I keep going here, what are some colors I haven't used? I've used that color blue. Let me use a different color blue, I guess. Let's use the green here. So the 9 times 2x squared is going to be plus 18x squared. Now you could also write that out here, but you can tell I'm running out of room and writing it vertically. I've seen a lot of students who like that, so I'm going to back this up and say that's what I'm going to do here. So I'm just putting it under the x squares. I'm lining them up, right? Lining those up. So I'm going to do the same thing with the next thing. I'm going to line it up. So we're going to say the plus 9 times the plus 4x is going to be plus 36x, right? 9 times 4 is 36, and then 1x. And then finally, I'm going to multiply what? The plus 9 times the minus 11 is going to be minus 99. And then I'm going to say, okay, look, I did all this. What is it going to total to here in the end? So I lined all my things up. The 10x cubed had nothing with it, so it's going to stay 10x cubed, or 10x to the third. Then I have a positive 20 and a positive 18. Both of them are x squared. When you add or subtract like terms, you get a like term. It's going to be x squared. 20 plus 18 is what? 38. So this is plus 38x squared. Then we have x's, right? Like term is going to be a like term. It's going to be an x. But I have minus 55 plus 36. So how far is 35 from 55? 20, and it's one less than that. So this is going to be 19. And then which one's bigger? The 55, so it's minus 19x. And then finally, minus 99. Minus 99. So 10x cubed, I'm not going to do it with that color. 10x cubed plus 38x squared minus 19x minus 99. Now notice I've changed my functions. I got capital F, capital G, and capital H. It's not necessary that I change to capitals or anything. I just 3 new functions. I have a polynomial, which is a line, x plus 1. I have a radical with an even root, 4x plus 7, another radical, and then a fraction, 1 over 3x plus 2. And I want to find f minus g. F minus g. That literally just means f of x minus g of x. Okay? So this is going to be x plus 1. If you want to put it in parentheses, minus g of x, square root of 4x plus 7. Now here, the parentheses were unnecessary. Why? Because g of x is only one term. Mr. Guess has got 4x plus 7. I understand, but it's under the radical. That's one term. It's 2 terms inside the radical, but the overall g of x is one term. So here, if I do it without the parentheses or write it without, it's going to be x plus 1 minus the square root of 4x plus 7, and that is just fine there. So here, on this one, you have a restriction to the domain, no restriction, so the domain of g would actually be the domain of both of those together, okay? In any format of, outside of dividing and having to get rid of a denominator, it would be the same thing for add, subtract, or multiply. Not going to do it here, but just talk about it and say that's what it would be. GH, G times H. So this means G of x times H of x. So that's going to be, I'm going to put it in parentheses, plugging it in, 4x plus 7 in a radical, times H of x is 1 over 3x plus 2. So if you remember, okay, if you recall, this is really over 1. So if you multiply straight across, you get the square root of 4x plus 7 times 1, right? Over the denominator is 3x plus 2. So there's your final answer there, right? So that one, intersection of the 2 domains, you'd have to be greater than this over here and then not equal to 0 over there, and make sure that you mark everything out that needs to be marked out and only include what you need to include. Okay? And then h over f, this is going to be h of x over f of x. And so h of x is going to be 1 over 3x plus 2 over f of x is x plus 1. Oh, wait a minute. Good gracious. What is this? Actually, I want to use this color. This is really over 1, isn't it? So you got a fraction over a fraction. That's going to be 1 over 3x plus 2 times, you flip this one, 1 over x plus 1. So that becomes 1 over 3x plus 2 times x plus 1. For me, that's a beautiful answer, okay? Because then you have the denominator already factored. If you wanted to find out about domain, you could set both those things not equal to 0, restrict the domain that way. If you were finding asymptotes, boom, you got those already ready set up for you to do, that kind of stuff. So if you multiply it out, I'm probably going to give you credit too. Your teacher may want that. That is actually truly simplified. To simplify is to remove parentheses and combine like terms. To truly simplify, you would FOIL this out, okay? I'm going to allow this as an answer because many, many, many times in math, you want it factored. And so since it's already factored, let's just leave it there, okay? But if you gave the other answer, that's fine as well, all right, for me. So I guess technically I should probably write it over here and say what it is. That's going to be 3x squared, right? And then you're going to get plus 3x plus 2x is what? Plus 5x. And then plus 2. So there's your OR answer there, or one or the other, all right? I'm just fine with the one on the left, even though technically it's not simplified. When you have a fraction, I always want it factored to see if anything divides out, and then leaving it factored is wonderful because with the exception of like horizontal asymptotes or some kind of limit or something, I haven't encountered things in math that don't want it factored or don't need it factored to keep going. So hope this helps out with combining functions.